Accelerated global climate action is critical to meet the enormous challenges posed to communities and ecosystems by the unraveling climate crisis. The CDRI Fellowship Program invests in innovative, actionable, and scalable solutions at the local level that demonstrate the potential to address global infrastructure resilience challenges. Through its fellowship, CDRI has been nurturing a diverse and inclusive pool of change agents and innovators across the globe, working towards the resilience of infrastructure systems. The first two cohorts of fellows, comprising 34 teams from 14 countries, have generated a rich range of potential solutions and knowledge outputs, addressing diverse infrastructure sectors and hazards. Cohort 2023-24 Fellows, comprising 18 teams from 13 countries, are on the cusp of completing their fellowship, and we are excited to share their journeys with you.
My project aims to enhance understanding of urbanization's impact on floods and social vulnerability, fostering resilience in flood-prone urban areas. Thanks to CDRI's support, I conducted surveys, organized focus groups with local communities and experts, and facilitated a high-level workshop with international experts. This approach fosters interactive exploration of urban transformation scenarios to mitigate flood risks. Grateful to CDRI for making this possible.
My name is Can Zulfikar from Istanbul Technical University. Our project title is Earthquake Resilience of Healthcare Facilities in Kocaeli Province in Turkey. I thank to CDRI for their support in the project that we had a good progress so far. We developed an inventory, we carried out seismic hazard analysis, we selected 3 typical hospital buildings and instrumented them. Currently, we are working on the performance assessment analysis. Then we will continue with the resilience analysis, and then we will work on the dissemination works with the local authorities and stakeholders. So I believe we will have a good project outcomes. Thank you, CDRI.
Welcome to nature. We are revolutionizing the way we build and maintain unpaved roads in developing countries through nature-based solutions.
We are pioneering the use of biostimulated MICP as a sustainable alternative. Unlike conventional MICP, our approach minimizes toxic byproducts. So far, we have characterized the soil, built an erosion equipment, and established a biosedimentation treatment protocol. Now, we are moving to mechanical and erosion tests on treated samples.
Our research aims to reinforce unpaved roads, promising environmental savings and improved well-being for local populations. Stay tuned as we pave the way to sustainable infrastructure.
This study is aimed at forecasting inclusion of sustainable urban drainage system in flood management using hydraulic modeling techniques. Such have the potential to lower the peak and increase the time to peak, thus allowing existing drainage systems to work as effectively as possible and at the same time lower the depth of accumulated water. The 3 study areas have been chosen based on their land use, and 3 different methods have been used to complement each other. The study has also enabled us to appreciate the 3 pillars behind the achievement of climate resilient infrastructure.
So these are the problems that we face in Bhutan. So we have developed 3 objectives. Objective 1 is to develop BLI mobile app, that is Bhutan landslide information. Objective 2 is to develop digital landslide risk map and then storing BLI. Objective 3 is to develop landslide database and then storing BLI. So regarding the update of the project, we are completed with developing landslide risk map. We are also completed with developing mobile app and database. Currently, we are integrating landslide risk map in the mobile app. So this is landslide risk map of Bhutan. So it has different toolbar like geolocation, search, zoom in, zoom out. So any user can find their own geolocation with the landslide risk zone. So this is the mobile app with the database. So CDRI help us in professional development and career enhancement. Thank you for the CDRI.
In the heart of towering peaks lies a community resilient against nature's fury. But as climate patterns shift and disasters become more frequent, we must adapt. Through a multi-stakeholder collaboration, we empower communities with knowledge. From rapid risk assessment workshops to engaging stakeholders, we are building a network of resilience. Together, we are creating a blueprint for resilience. Our learning modules will equip individuals and institutions with the tools to face any challenge nature presents. In this journey, we extend our heartfelt gratitude to CDRI for their support. It's through the collaborative efforts that we can bring our vision of enhancing disaster resilience in mountain geographies to life.
Saludo la beca de investigación sobre amenaza sísmica, inundaciones y vulnerabilidad física de edificaciones en la zona costera sur del municipio de Barahona, de la República Dominicana, nos ha permitido conocer los diferentes tipos de tipología constructiva en la zona y su vulnerabilidad ante un evento sísmico. Además, conocer la zona más vulnerable a inundaciones por el desbordamiento de ríos, arroyos y cañadas. Estos resultados se darán a conocer a las autoridades competentes para la toma de decisiones y a la población en sentido general.
Direct and indirect exposure to untreated wastewater in government schools poses risks to both human and environmental health. To address this at HG, we are developing decision-making web tool called EcoWise. We are currently developing the algorithm using data collected from 23 schools located in urban, peri-urban and rural areas in Bangalore. The data is collected on water supply, grey water quantity and quality, socioeconomic factors and waste management practices. Once operational, EcoWise will expedite the process of identifying optimal school-specific treatment designs, eliminating the costly surveys typically required for these treatments.
For the Deep INRA project, which is a flood inundation detection tool using deep learning and citizen science, one of the challenges in detecting floods is that there are resolution limitations to the kind of data that we can collect from satellites. So the idea is that we can combine synthetic aperture radar with deep learning and also with citizen science data to be able to better detect flood inundation in a high resolution. So for this, we have developed a tool called Deep INRA, where we have combined huge amount of synthetic aperture radar data that we have collected over the years with deep learning. And this tool is now able to detect riverine and urban floods in a much more efficient fashion. I look forward to sharing updates on that project with everyone in the fellowship. Thank you.
To ensure community resilience quantitatively, the cyclone classifier model CCM has been adopted in the CDRI fellowship project to assess the status of critical infrastructures, namely the embankment and housing, against real-time cyclone and essential data in the pre-disaster and post-disaster phases of recovery. The tool is well received at the national level, earning an adaptation as well as by the local community and administration. Now it is in the process of mainstreaming at the National Resilience Program and has potential to use it in other countries as well.
Our project focuses on ways to cool down cities to reduce the impact of heat. We are looking at things like urban parks, urban ponds, and other measures that can make our cities cooler. We quantify the spatial extent of these cooling measures and offer a decision support system to help urban planners decide where to put them and how big they should be. Thanks to the fellowship, with this CDRI fellowship program, we have developed a system which is now scalable that can be used in any city.
Our project aligns with just energy transitions and adds the resilience perspective to it by understanding agrivoltaics as components that add to redundancy in the existing energy system. To understand the feasibility of the same, we are building on the economic, regulatory, and local community perspectives. Simulation studies are currently being carried out to evaluate the technical feasibility and model selection for the identified sites of Nagpur metropolitan area. To that effect, CDRI has been adding utmost value by introducing us to the wonderful mentors who have supported and shaped this project. This fellowship has led us to understand the localized climate action specifically in the context of just and resilient energy transitions.
Bangladesh is a mega shopping center of natural hazards, and cyclone affect Bangladesh almost every year. We are providing a framework for community disaster resilience assessment for cyclone hazard, which will integrate functionality of building and critical infrastructure system like electrical power network. Our approach is being applied to a coastal city Chittagong in Bangladesh, which will incorporate physical infrastructure damage, socioeconomic impact, and other consequences. Our project will deliver an open source Python tool for community cyclone resilience assessment for scenario cyclone hazard. We thank CDRI for their support through the fellowship to conduct the study.
Hello everyone. Our team at the National Institute of Urban Affairs are implementing the Action Research Project SADAN, that is Strategic Actions to Build Resilience for All. The research focuses on contextualizing the needs of persons with disabilities and aims to develop localized strategies to build their resilience from disasters, particularly cyclones. Given the nature of the disaster we have chosen, our study is anchored in the district of Ganjam in Odisha. Beyond generating evidence on the degree of impact on the marginalized groups, the project outcomes will also create tools to steer better policy outcomes at the state and the district level.
Hello everyone. I am excited to share the opportunity given by CDRI, the sole funding fellowship of my research, which is about incorporating urban greenery, detention pond, flood management in the Mamahuman Basin in Ghana. The stakeholders are key in this project and are looking forward to the research results. So far, we have been able to have an interaction with the key stakeholders and have carried out drone videos, images, meteo data, LiDAR data, as some field works. The real results will have an impact in the local communities in the basin, since the proposed solution largely lie in the hands of the local authority or assemblies within the basin to be implemented. Thank you very much.
We study and looked up wetland due to its unique biodiversity and indigenous communities under threat of disasters. Using PPSRI framework and spatial analysis, we first developed a vulnerability index. Further, using stakeholder participation, we formulated a regression model. I'm thankful to CDRI and technical experts for their continuous support and guidance throughout the project.
The CDRI project is an assessment of the effectiveness of nature-based solutions in flood risk management in the city of Brandon, Manitoba, Canada. The project utilizes a stakeholder engagement and consultation process to measure the effectiveness of nature-based solutions in flood risk reduction based on scenarios. A number of stakeholder engagement sessions have been held. The software to simulate the scenarios have been acquired and simulation parameters have been defined. The outcomes from the project will inform flood risk reduction policies and interventions in both the private and public sector.
My teammates and I are developing a debris flow early warning system that makes use of rainfall data and detects both ground vibration and infrasound in the initiation and propagation phases. Before installing our experimental stations, we carried out a risk mapping exercise to identify 2 catchments among 17 that are most worth of investigation. Our stations are on the ground now, and we are waiting for the forthcoming intense rainfall season in the Italian Alps. We are very grateful to CDRI for its support. Thank you.